Today I am going to discuss about relative density. That means we are going to compare density of a substance, relate the density of a substance with the water. Now the question is, why with water? Because what is the only liquid which has the density 1 gram per centimeter cube, provided it is pure. Okay. So we are relating density of every substance with that of water. That is relative density. Okay. Now first of all, let us express this mathematically. The definition says that it is the ratio of density of a substance to the density of water at 4 degrees Celsius. But why 4 degrees Celsius? Because water has maximum density at 4 degrees Celsius. Okay. So relative density is defined as, this is the relative density of a substance, because you are comparing with this water. So relative density of a substance equals to density of a substance divided by density of water at 4 degrees Celsius. Okay. Now, so we compare the relative density of a substance, expressing is at a ratio of density of a substance to the density of water at 4 degrees Celsius. Now from this we have a relation. Suppose you want to find the density of a substance and you are given RD. This is RD. Okay. Then you can write this density of a substance equals to RD of the substance multiplied by, now when you are multiplying means you are cross multiplying these two. Okay. To get the density of substance, we are multiplying RD of the substance with the density of water at 4 degrees Celsius. Now this is density of water at 4 degrees Celsius, right? So everything is very clear. If you want to get RD, divide the density of substance by density of water at 4 degrees Celsius. If you want to find density of the substance, multiply the RD of substance by density of water at 4 degrees Celsius. Now the question is, which unit you want? If you want to get the density in CGS, that is gram per centimeter cube, simply multiply the RD with 1 gram per centimeter cube. You know why? Because the density of water at 4 degrees Celsius in CGS system is 1 gram per cm cube. This will give you the density of the substance in CGS, that is gram per cm cube. On the other hand, if you want to find density in MKS system, that is SI system, which means kg per meter cube, okay, then simply multiply the RD with 1000 kg per meter cube. One thing you might notice, I haven't written any unit for RD because RD is a pure ratio. Pure ratio means the density of this and density of this both are in the same unit, they get cancelled. So these type of mathematical relations will have no unit. So RD has no unit. So multiply the RD with gram per cm cube, this will give you density in CGS. If you multiply with 1000 kg per meter cube, you get the density in kg per meter cube. Okay. Now how are these two related? Density in gram per cm cube, if you want to convert into kg per meter cube, simply multiply by 1000. This will give you density in kg per meter cube. Okay. And if you want to go from kg per meter cube to gram per cm cube, then simply divide it by 1000, right? So gram per cm cube into kg per meter cube, multiply by 1000. kg per meter cube to gram per cm cube divided by 1000. So this is how you can convert from one into another. Now we are going to discuss about how to get the RD of a substance, okay, using a relative density bottle. So suppose you want to find the RD, relative density of a liquid, okay, then in that case we use a measuring bottle known as the relative density bottle, okay. Now look, suppose we give an observation over here. This is an empty bottle whose mass is 50 gram, okay. This is containing nothing, okay. This is the empty bottle and we are taking a liquid water up to the brim. This is water and the mass of this bottle filled with water, okay, this is recorded as suppose 60 gram, and a third bottle is same as this. That means you are emptying this, replacing this liquid water by a liquid X. That liquid could be anything excepting water. It could be alcohol, benzene, anything. So let's take liquid X, okay. This is having the mass, let us take 70 gram. So the three observations are very clear. This is the empty bottle having the mass 50 gram. This is filled with water up to the brim having the mass 60 gram. This is the bottle with liquid X having the mass 70 gram, okay. Now you have to find the RD of liquid X, right? This liquid X, the RD you have to find out. Now suppose you want direct question. Direct question is there to find the RD of liquid X. Then you can apply this formula: mass of liquid X divided by mass of same volume of water, okay. So what is the mass of the liquid X? The liquid X is, along with bottle, 70 gram. From this you subtract the mass of the empty bottle. So the mass of liquid X is 70 minus 50, 20 gram, divided by mass of same volume of water. Now what is the mass of water? 60 gram is the weight along with this, and empty bottle is 50 gram. So subtract 50 gram from 60 gram. This is giving you the mass of liquid water. So that comes to 20 by 10, because RD has no unit. So this is 2. This is the expression for RD of liquid X, right? Now from this RD, if you want to calculate the density of liquid X, multiply by 1 gram per cm cube if you want in CGS, and multiply by 1000 if you want to get in MKS, that is kg per meter cube. Now the same question could be asked in detail, okay. This is specially recommended for students of class 8, okay, and 9. Suppose in this same observation you have to find the RD of liquid but there are some questions which are asked intermediate, that is you have to find the capacity of the bottle, then mass of water, mass of liquid, density of liquid, like that, okay. So I am giving you 7 steps for this. First of all, to find the mass of water, we have the expression mass of the bottle with water 60 gram minus mass of empty bottle, that is 60 gram minus 50 gram. So this comes to 10 gram, okay. Now second is we are going to find the volume of water, okay. volume equals to mass divided by density. Okay, mass of water you have got 10 gram, density of water is 1 gram per centimeter cube, so this comes to 10 centimeter cube. Okay, this is the volume of water. Third, volume of the bottle. Okay, that means you want the capacity of the bottle. Capacity means volume. Exactly. If the bottle can accommodate 10 cm cube of water, it means the capacity of the bottle is 10 centimeter cube. So both are same. This is also 10 centimeter cube. There could be questions based on this subheadings. Okay. Fourth, now you are finding the volume of liquid X. Now this liquid X will also have the same volume as the volume of water because the capacity of the bottle is not changed. So this is also 10 centimeter cube. Okay. So all three are same. Volume of water, volume of bottle, volume of liquid X. Now let's come to mass of liquid X. This is equal to mass of liquid with the bottle, that is 70 gram, minus the mass of the empty bottle, that is 50 gram. So this comes to 20 gram. Now you can find the density of liquid X, which is equal to mass by volume. Okay, the mass is 20 grams, the volume is 10 centimeter cube, so it's coming 2 gram per centimeter cube. Okay, now the seventh step is you have to find the RD of liquid X. Okay, if directly the question asks about liquid X RD, you can apply this formula: mass of the liquid X by mass of equal volume of water, which is one step equation. But here there could be several questions attached to this. And at last, RD of liquid X, that is, apply the formula density of liquid X, because you know this value, that is 2 gram per cm cube, divided by density of water. So it comes to 2 gram per centimeter cube divided by density of water, that is 1 gram per cm cube. So it's 2. Okay, the value of RD comes to 2. So both are giving you the same results. It depends upon what the question is asking and what steps you need to show. Is that clear? I hope these calculations are clear to you. Okay, so you may solve questions from class 8 book. Okay.